Hello, it's Sainz and I'm going to present the first part of 4 videos about the harmonic problem solutions. These videos are the last sessions about harmonics. In these sessions, first of all, I will introduce a guide for choosing the best solutions. In next videos, I will develop the different proposed solutions. The analysis of the harmonic problem and the proposed solutions in electrical installations polluted with harmonics due to the presence of nonlinear loads should be made following this schedule. First, we must make measurements of currents consumed by nonlinear loads and voltages at the point of common coupling in order to characterize the harmonic distortions. These results can also be derived from the resolution of the harmonic problem as it was presented in the 9th, 10th and 11th videos. The previous results may allow to identify the harmonic perturbations and the origin of the harmonic problem, and to propose the corresponding solutions. The location of these solutions in the load, secondary and main distribution panels must also be decided on the basis of the analyzed harmonic problem. Broadly speaking, the solutions can be divided into 2 types. Solutions relate to the installations and nonlinear loads, and solutions relate to reactive power compensation equipments. We will decide one of them depending on the harmonic problem detected in the installation. Regard to the solutions in the installation and nonlinear loads, we can separate between the filtering equipment and other particular and more specific solutions, as the third harmonic filters, the electromagnetic interference filters, and the immunized residual current devices. In the following table, we have a guide about the main perturbations, the origin of these perturbations, the possible solutions, and their locations. So, this table will be useful as a guide for choosing the best harmonic problem solution. Regard to the installation and nonlinear load solutions, we have the following issues and solutions. The overload of the neutral conductor due to the third harmonic circulation in the neutral conductor current. The solution will be the third harmonic blocking filter placed on the neutral conductor. Another perturbation will be the interferences in the electronic equipment due to the high frequencies conducted. The solution is the high frequency filters located at the load panel. Next is the residual current device strip due to the high frequency current leakage. Solutions are immunized residual current devices and the harmonic filtering equipment. Former located at the main distribution panel, later located at the distribution panels. And the last perturbation about installations and nonlinear load solutions is the heating due to overload of equipment and facilities. This is due to the existence of harmonics of different ranges, and the solutions are the harmonic filtering equipments located at the secondary and load distribution panels. Regarding to the reactive power compensation equipment solutions, The main issue is the capacitor bank overload, electronic control problems, and vibrations due to the resonances between the capacitor banks and the reactance of transformers and grid. The solutions are capacitor bank protections and the resonance mitigation equipments, which are placed at the main distribution panel. So, given an electrical installation, we must analyze and identify one of the presented concerns and apply the solution suggested in the table. Next videos develop in detail the solutions presented in this video. Hello, I am Sainz, and this is the continuation of the previous video about the harmonic problem solutions. In the first video, I introduced a guide for choosing the best solution for the harmonic problems, and in the present exposition I will present the solutions to solve specific or particular problems in electrical installations. In the first video, the harmonic problem solutions were divided in those applied to the electrical installations and nonlinear loads and those applied to the reactive power compensation equipments. In this video, I will explain some of the installation and non-linear load solutions. In particular, I will present the third harmonic blocking filters, the high-frequency filters, and the immunized residual current devices. As it was presented in the 14th video, the neutral conductor current is not zero in presence of balanced single-phase nonlinear loads, because the harmonics multiple of 3 flow through this conductor with a root mean square value 3 times the root mean square value of the phase currents. This can produce the overload and the heating of the neutral conductor current. So, in general, the cross-section of this conductor must be equal or greater than the cross-section of the phase current when the electrical installation supplies single-phase nonlinear loads. However, there exists the option of installing a third harmonic blocking filter in the installation when the designed cross-section of the neutral conductor current is not enough to drain these harmonics. The third harmonic blocking filter presents a high value of the impedance at the harmonic to be eliminated. Therefore, this harmonic does not flow through the neutral conductor. In order to select this filter, the nominal voltage, the frequency, and the current is required. High-frequency perturbations produced by power electronics can pollute with high-order harmonic currents the electrical installations. EMI filters can be connected in order to avoid this issue. These devices filter the harmonic currents, avoiding their penetration in the electrical installations. The residual current device measures the current flowing through all active conductors of the installation. It detects any residual current due to an isolation fault, and it opens the switch to eliminate this residual current. Power electronics produce high-frequency harmonic currents which can flow through the parasitic capacitors of the device towards ground as the residual currents. These high-frequency currents may trip the residual current switch when they are measured. In this condition, the residual current device opens the electrical installation when power electronics are connected, but there is no fault in this installation. To avoid this problem, it can be installed immunizer residual current devices, which have a high-frequency filter to block the high-frequency currents measured by the device, avoiding the switch opening. The main characteristics of the immunizer residual current devices are the voltage, the rated current, the sensitivity of the trip current, the delay of the switch trip, and the class.